is on solving inequalities using critical points. So it says in Algebra 2 you worked with linear inequalities. There were no powers on the exponents. We also did a little bit with quadratic inequalities where we had like parabolas dipping below the axis. So let's review the linear inequalities first, and then we're going to move on to the nonlinear ones. So in number 1, pretty easy, right? So we're going to get everything, all the x's on one side, so I could subtract 12x. And when I do, I get negative 6x plus 6 is less than negative 20. I can subtract the 6 and get negative 6x is less than negative 26. And then when I divide by negative 6, do you remember what we need to do? Yeah, we flip the sign. I always call that the red flag rule. If we divide or multiply by negative, we have to flip it. So we're going to do x is greater than 26 over 6, which is 13 over 3. Okay, so it's okay to have gross numbers. I'm not asking for a very precise number line. I think in Algebra 2 they make you put in like 0, 1, 2, like that. Or in Algebra 1, I mean. I don't do that. I just have you slap 13 over 3 somewhere on the number line. And then we say, oh, it's everything that's bigger than 13 over 3. So then we know how to write it in interval notation, so it looks like 13 over 3 to infinity. Since we didn't fill in the circle for 13 over 3, we have an open circle and we have a parenthesis instead of a bracket. Does that make sense? All right, so the next one. So I'm going to subtract the x. I could subtract the x over and have 3x over here. And then subtract the 27 and get negative 18 is greater than or equal to 3x. Divide by 3, I get negative 6 is greater than or equal to x. So what that means is x is smaller than negative 6. So when I put it on the number line, I have negative 6. I have a filled in circle, everything to the left of it. So it's going to look like negative infinity to negative 6 with a bracket on it. Does that make sense? All right, so sometimes we have them kind of in between. So if you remember on these ones, when we have like 3x minus 5, and I'm just trying to get the x by itself, I know I'm going to add 5 to each location and then divide by 3. So in that case, we would just add 5, add 5, add 5. So we get 9 is less than or equal to 3x, which is less than or equal to 23. And then we would divide everything through by 3. So we'd have, when we divide everything through by 3, did I make a mistake?
Yeah, after 9, it's not less than or equal to, it's just...
Oh, okay. I thought I messed up on the 23. I was like, I should have made this problem nicer. All right, I'll give that to Olivia, although a couple of you guys did have your hands up, so just shout it out. All right, so we get 3 is less than x, which is less than or equal to 23 over 3. All right, so putting that on a number line, x is sandwiched between those two. And you can kind of make sure 23 over 3 is bigger than 3. It is, right? That's a weird 3. All right, and then we have open on the left and closed on the right side and everything between it. So it ends up looking like parentheses 3 to 23 over 3 with a bracket. Okay. But I told you Algebra 2 is a bit of a step, or Precalc is a bit of a step up from Algebra 2. So like we didn't do ones like number 4, but we should have. They're really not that bad. So the best way to do this is to separate it into 2 inequalities. Do you see how this one is different than number 3? What looks different on it? Yeah, there's x's in all, like both locations, right? So I can't like isolate an x in the middle because of that. So what I'm going to do is I'm going to write my 2 inequalities. I'm going to say 2 is less than 3x plus 5. And I'm going to say 3x plus 5 is less than or equal to 2x plus 11. And then I just do both of them. So I'm going to subtract the 5 over and then divide by 3. So do that on the first one. All right, so I'm going to have negative 3 is less than 3x. And I'm going to do x is greater than negative 1. So that's how that's read. X is bigger than negative 1. Right, do you guys remember the cheesy alligator thing? Alligator wants to eat the bigger number. All right, and then this one, I'm going to subtract the 2x, so I have x plus 5 is less than or equal to 11. I have x is less than or equal to 6. So when I put this on my number line, I'm saying x is greater than negative 1, but also less than or equal to 6. and we need both things to be true. This is called a compound inequality, so it's like an and statement. Like this is true and this is also true. So our answer would be -1 to 6 with a bracket. Still feeling pretty good about these? Not too bad. All right, so let's move on to some of these more complicated ones, like these nonlinear inequalities. So it says if we have a more complicated inequality, such as x squared minus 3x is greater than 4, we need to use critical values. So if I have x squared minus 3x is greater than 4, I first get everything on one side and I set it like greater than 0 in this case. And I'm just going to find what I call critical values, the numbers that make it equal to 0. Now we're also going to have numbers that are going to make it undefined in this section. So if you look like forward to these ones, where we have rational functions, those are also going to be critical values when the denominator is equal to 0. Okay, and we'll talk about why that is. Okay, so if I factor, I'm going to get x minus 4, and I'm going to have x plus 1. So I get x equals 4 and x equals -1. So when I put those on a number line, I'm going to test in each location. But I want you guys to be even smarter than just memorizing a process. I want you to think about what this means. Okay, what we just have is we have a parabola, right? If I was graphing what it looks like, it's a parabola. And I just found the zeros, the x-intercepts of the parabola. So imagine I have my grid, and I have at -1, and I have 4, and I have this parabola that's crossing through there. Is it an upwards parabola, or is it a downwards parabola? It's an upward, so if I was sketching it out, it's going to look something like that. Do we agree? Okay, what we're asking for is when this parabola, x squared minus 3x minus 4, is greater than 0. Where is it higher than the x-axis? In the middle or on the ends? On the ends. You can see here and here, it's above the x-axis. Okay? So really, you can kind of outsmart the system if you just have some knowledge about graph theory. If you can say, oh, wait, I kind of understand what this graph looks like. So I know that the ends are going to be above the axis and the middle was in between. So if these are above and this is below, right, I have positive numbers on the left and the right and then negative numbers in the middle. All right, so I want it where it's greater than 0. I want where it's positive, so I want this side and this side, and then open circles here because that was just where it was equal to 0. So our answer would be -∞ to -1 union 4 to infinity. But that's not exactly, I guess I showed that to you guys in Algebra 2 if you were in my Algebra 2 class, but what we typically did is we just plugged things in. We checked to see if it made it true or false, and we plugged it into here. And sometimes I make like a little chart, and I'm like, okay, let's plug in something on the left of -1, like -2, something in between, maybe 0, and then something on the right of 4, 5. Do you guys remember doing this? And then we would check it in x minus 4 and x plus 1, and we want it for it to be greater than 0. So we're like, oh, when I plug in -2, I get a negative, and I get a negative. When I multiply, they become a positive. When I plug in 0, I get a negative times a positive. When I multiply, they get a negative. Does that make sense? And then 5, I have positive, positive, they multiply to be a positive. So you can do that process if you want, but if you just know what the graph looks like, save yourself some time. Okay? So we'll do a couple of these. So we have our steps. So it says get the polynomial on one side of the inequality sign, find all zeros. Write the zeros on a number line in increasing order, so in the order they appear. The spaces between the critical numbers are called test intervals. Choose numbers in these test intervals and test them in the original inequality or its factored form. If you get a positive number, we write plus above the interval. If we get a negative, we're going to write a minus. Decide if your solution set should be positive or negative. Is it greater than 0 or is it less than 0? Did step number 1 say greater than 0 or less than 0? Write your solution in interval notation. Okay, so we're going to go through this process. So the first one, so what kind of shape do we have? A parabola. Is it upwards or downwards? It's upwards. So if I factor this, I get x minus 6 times x plus 3. So if I'm finding my critical values, I'm setting each parenthesis equal to 0. So I get critical values, or critical points if you want, of 6 and -3. So on my number line, I put -3 and 6. And then you can think, oh, I just have an upwards parabola that goes through the x-axis at those values. So it's positive on the left, negative on the middle, positive on the right, meaning the y values are positive on the left side, the y values are negative. They're below the axis in the middle, and so on. Does that make sense? So we want where it's less than or equal to 0, so our final solution is going to be in here with the endpoints shaded. So it should be bracket -3 to 6. Done. So could you go through the process and plug in numbers in each interval? Sure. I could pick -4 and plug it in here and have a negative times a negative is positive. That doesn't work. We wanted less than or equal to 0. I can plug in 0. 0 minus 6 is negative. 0 plus 3 is positive. Negative times a positive is negative. That does work. So any number I would have picked between -3 and 6 would work. Does that make sense? And then I can plug in like 7. 7 minus 6 is positive. 7 plus 3 is positive. Positive times positive is positive. We wanted less than or equal to 0. So it doesn't work. Does that make sense? Okay, so this next one. So we're going to subtract the 2x squared over. So when I do, I get x squared. I have minus 3x is less than 4. So I have x squared minus 3x minus 4 is less than 0. I think that's the same one we just did, actually. It is. So same as example. So you would factor, you'd get critical values of, just like we just did here, -1 and 4, and you'd test in each location. Or you could think about the shape. All right, so same idea here. So I'm going to subtract the 3x squared. When I do, I get 2x squared. I have my plus 3x. I have greater than or equal to 2, so I'm going to subtract the 2 over as well. 2x squared plus 3x minus 2 is greater than or equal to 0. So go ahead and try to factor. I'll probably make them so they factor too. I'm not going to give you weird ones you have to find on your calculator or with quadratic formula. That'd be mean. So I get 2x and x. Think about where we can put. So we want 1 and 2 for our last numbers, right? But we can't put the 2 right here, because if we put the 2 right there, we would have a GCF. Remember, these are the tricks we learn along the way that make us better at factoring. We didn't have a GCF in the line above, so we can't have a 2 that's a GCF. So we're going to put the 2 in the other location. I'm going to put a 2 here. And then I'm going to put a 1 here. And now I'm checking my outer and inner swoop. So I have 1x and I have 4x. Those can combine to be positive 3x if I put a positive with the 4 and a negative with the 1. So I have a negative with the 1 and a positive with the 2. And then I just quickly make sure that I didn't mess up my last sign. So I have -1 times 2, which is good. It still makes -2, so we're good. So to get my critical values, I set 2x minus 1 equal to 0 and x plus 2 equal to 0. So it looks like I get 1/2 and -2. Still with me? All right, so we put those in order on the number line. So I have -2 and I have 1/2. And we're finding where our upwards parabola is greater than or equal to 0. So our parabola crosses at those 2 points, so it's greater than or equal to 0 on the ends. Right, so our answer would be -∞ to -2. Parenthesis or bracket? Bracket, because we have those filled in points are included, right? We wanted the places where it was equal to 0 as well. Union, bracket, 1/2 to infinity. Make sense? All right, so don't be surprised if I ask you a question in a different way. So this next one is asked a little bit differently. It says determine the value of the variable for which the expression is defined as a real number. Well, there's a square root there, and we know that square roots are undefined when we have what underneath a square root? A negative. So we don't want negatives. We want this part in here to not be negative. So we can't have this as a negative. So we're going to say that x squared plus 5x plus 6 has to be greater than or equal to 0. Right? That's the only way we can take the square root. KJ, you with me? You look so tired. I'm sorry. I can't pep it up. I can't like do an acrobatic act up here or anything. Unicycle with fire. I was telling my calc class the other day that we went to so we had a university talent show several years ago, probably like 10 years ago. Well, I wasn't here 10 years, so like 7 years ago. And you know, talent shows, sometimes they're really good, sometimes they're not. You never know the talent that we have. And there was a boy named J.D. Hoover who got up there and had a unicycle. I was like, all right, he's got a unicycle. And then he lit some things on fire. He was juggling fire on a unicycle. And I was like, that's talent. It's the most impressive thing I think I've seen any kid do. So I am not going to do that for you, but I'm going to try to make it a little bit interesting. All right, so anyway, so I have x squared plus 5x plus 6, and we're going to factor. So we get x and x. What do we think? How do we factor this one? It's a tricky one. Yeah, it's just x plus 3 times x plus 2. So a lot of people think 6 and 1 because they're like, oh, 6 and 1 can combine to be 5. But think about your signs. So that works. So we get critical values of -3 and -2. So we put them in order, -3 first and -2 second. And then we say, okay, I'm going to have my parabola dipping down below the axis. So it's positive, negative, positive. So we want where it is greater than or equal to 0. Otherwise, we can't take the square root. So we're going to say, okay, it's going to be defined from -∞ to -3, including -3, and then -2 to infinity. Okay, and you can check things. So let's try things. So let's try like -4. So let's say I plug in -4 into my x squared. You don't have to write this, just kind of look up here. Does it make it okay? So I have 16 minus 20 plus 6. Is it positive? Yeah, we get the square root of 2. Can we take the square root of 2? Sure. But what if I picked a number in the middle? Like what if I picked -2.5? You can try it, you end up getting a negative. It doesn't work. What if we try something bigger, like 0? Does 0 work? 0 squared plus 5 times 0 plus 6. I get the square root of 6, right? Can I take the square root of 6? Yeah. So you can check things in the end and make sure that it works. All right. Moving on. So what if we have a cubic polynomial? So this one's not a parabola this time. So we have an x cubed shape. This is probably where I would start testing my points, okay? Because I think you guys are good with graphing parabolas and knowing, oh, a parabola crosses at these locations. But sometimes these ones will have things like multiplicity. So it's a little tricky. All right, so we're going to get everything on one side. So I have 2x cubed minus 3x squared minus 32x plus 48 is greater than 0. And we hope and pray that we can factor by grouping, can we? Let's see, because otherwise we'd have to do P over Q. But I told you I'm probably going to give you things that factor pretty easily. So I pull out an x squared, and when I do, I have 2x minus 3. So Ben, you said, yep, it does factor by grouping, so what do I need to pull out? -16, 4 squared, is that what you said?
Yeah.
You were already moving on to the next step. All right, we pulled out 16, -16, right? So now I factor the 2x minus 3 to the front, and I'm left with my x squared minus 16. Which is the difference of two squares. We know how to factor x squared minus 16. It's x plus 4 times x minus 4. So now I have 3 critical values. So I have 3 over 2, -4, and 4. So I put those on the number line in that order. So -4 first, then 3 over 2, which is like 1.5, and then 4. And I can then test in each location. Now, could you still do it the other way? Sure. If I was drawing like my axis in, it would be right there. And it's an x cubed shape. Can you all think for a second what x cubed looks like? Positive x cubed, right? So it's going to go up, down, up. If you want to do that, that's fine. Okay, so you guys can do that, and then you can say, oh, it's going to be, below the axis, above, below, above. So it's negative, positive, negative, positive. That is the fastest way to do this. But you have to have some knowledge of graphs in order to do that. Okay? So if we didn't know that, then we would plug in each location. So I'd pick a -5, and I'd go to this factored form. And I'd say, well, when I plug in -5, I get -10 minus 13, which is negative. -5 plus 4 is negative. -5 minus 4 is negative. A negative times a negative times a negative makes a negative. So it was negative, right? And then we go through the next one. So we're like, well, if I plug in something between negative 4 and 3 over 2, what's the easiest thing? 0. So if I plug in 0, I get negative 3 times a positive 4 times a negative. So I get negative times positive times negative, which is a positive. Yep, so it's a positive. And then I try something between 1.5 and 4. So I try like 2. And I'm like, oh, I get a positive. I get a positive. I still have a negative on the end. So it's negative. Do you guys know what I'm saying? So you can do it that way as well. So in the end, we want everything to be greater than 0. So we want from here, whoops, not filled in, right? Open, negative 4 to 3 over 2, open, and then 4 to infinity as well. So our final answer is negative 4 to 3 over 2, union 4 to infinity. All right, so do the x cubed ones make sense? Yeah, not too bad. All right, so let's move on to the rational functions. These are the trickiest ones. Okay, and the reason these are tricky is because you have to consider the denominator as well. Okay, so this is a kind of a tricky explanation, but what if I just had like 2 over x minus 3 is greater than 0? Okay, there's nothing that I can plug in for x to make this equal to 0. Think about it. Can you plug anything in for x to make it equal to 0? No, the only way you get a fraction, so it's 2 over something, equal to 0 is if that 2 could be 0 somehow. And it can't, right? Do we see that? So there's no way to get this fraction, 2 over a number, to equal 0. But there are things that make this negative. There are things that will make this inequality true. So let's think about things. What if I plug in 4? Do I get a positive is greater than 0? If I plug in 4? Yeah, if I plug in 4, I get 2 over 1 is greater than 0. Tell me something that makes it negative. A 1. If I plug in 1, what do I get? So I have 2 over 1 minus 3 is negative 2. I get negative 1, which is not greater than 0. Okay, so where's that like turning point? What's making it like on my number line? What number do I have to have on my number line so that on the right side of it it's positive and on the left side of it it's negative? Yeah, if I put 3 in, does it make sense? If I plug in anything bigger than 3, like 3.1, even a tiny little number, 3.1, I get 2 over 0.1, which is positive, right? But if I plug in anything smaller than negative, or smaller than 3, like 2, 1, 0, I get a negative out. Does that make sense? That's why we have to have critical numbers from the denominator as well. Yeah?
Wait, can you not have a 0 in the denominator?
Yeah, we're not allowed to have 0. So in this case, so what if I had said greater than or equal to 0? And I'd be like, oh, everything on the right side makes it greater than or equal to 0. What about 3? 3 doesn't make it anything. It makes it undefined, right? So in that case, we would put an open circle there. So we're going to have to be careful with our closed and open circles too. We have to think about, do they really make this inequality true, or does it make it undefined? All right, so let's look at this example up here. So we have x plus 6 over x plus 1 minus 2 is less than 0. We have to get it in the form where we have a fraction is less than 0. So we need a fraction is less than 0. So we're going to take this and we're going to get common denominators. It's annoying. I'm sorry. And we're going to combine it. That's probably the easiest way for you guys to do these. There's actually one more way. Maybe I'll teach you both ways. All right, so if I get common denominators, I have x plus 6 over x plus 1 minus 2. What do I need to multiply by on the top and bottom so that it has common denominators with the thing that's next to it? Yeah, x plus 1 over x plus 1, right? When we do, we're able to put it all over the common denominator of x plus 1. Then I have x plus 6 minus 2x minus 2 is less than 0. So I get negative x plus 4 over x plus 1 is less than 0. And so we get critical numbers from both the numerator and the denominator. So we're going to set both of these equal to 0. So our critical values are what two numbers? 4 and -1. Do we see that? We're then going to put them on the number line like that. And now it really is best to test in each location because I don't think you guys totally know what -x plus 4 over x plus 1 looks like. That was your homework for yesterday, right? But do we want to go through the whole thing, like find the horizontal asymptote, find the vertical asymptote, graph it out? No, it's like more time consuming than just plugging in the numbers, right? So if I plug in like -2, I'm plugging it in to my most simplified version. So if I plug in -2, do I get a negative or a positive on top and bottom? So -2 gives me a negative on top. No, not a negative, sorry. Positive on top and a negative on the bottom. So if I have a positive divided by a negative, I get a negative. Then I try 0. When I plug in 0, I get a positive 4 on top and a positive 1 on the bottom. Positive over a positive is a positive. And if I try 5, I get a negative over a positive, which is a negative. We want where it's less than 0. Those endpoints are making it, what if I plug in -1? I get undefined, right? So I can't include -1 in my answer. If I plug in 4, I do get 0. But do I want that one to be shaded? No, because 0 is not less than, or it's not less than 0, it's less than or equal to 0, right? So it's not included in our final answer. So we get -infinity to -1, parentheses, 4 to infinity, like that. Make sense? All right, so the same idea on this one. So we have 2 minus x over x plus 4, and we're going to subtract the 5 over, because that 0 thing's important to us. We like to see if it's like positive over negative is a positive, and so on. So we're going to get common denominators by multiplying by x plus 4 over x plus 4. Oops. So when I combine, I have 2 minus x minus 5x minus 20. Do you guys see how I got that minus 20? So I have to distribute this -5 into both of those. Brooke, you with me? Brooke looks very sleepy back there. So we get -6x minus 18 all over x plus 4 is greater than or equal to 0. So to find my critical values, I set my numerator equal to 0 and I set my denominator equal to 0. So I end up getting, what, -3? And -4. So then I put them on my number line. -4 comes first, then -3. And I test in each location. So you could test back in the original, but I don't like to do like greater than or equal to 5. You know, I like it to be greater than or equal to 0, because then you're just seeing if it's positive or negative. You don't care what the number is, right? So if I plug in -5, I get 30 minus 18 is positive over a negative. So positive over a negative is a negative. If I tried -3.5, I get something a little bit bigger than 18 minus 18. So it's positive over -3.5. A -3.5 plus 4 is going to be positive. So I get a positive over a positive, which is positive. It doesn't always alternate, so don't assume it alternates too. I always say that, and then I give you ones that always alternate. I need to give you some that have like multiplicity or something. Do you guys know what I mean by multiplicity? So if you had an x cubed one, if it came up and it bounced there, then it would be negative, positive, positive again on the number line. All right, so then if I try something bigger than it, so 0. -18 over +4 is negative. So now be really careful with your endpoints. One of them's filled in, one of them's open, so think about it. What do we think? If I plug in -4, does it make it true? Yeah, what do you think, Howard? Yeah, -4 is open, -3 is closed. And we want everything that's greater than 0, so we want everything in between. So it's going to be parentheses -4 to -3, and then a bracket on the -3. So the reason is because if I plug in -4 to check, I get positive 24 minus 18, so 6 over 0. Is 6 over 0 greater than or equal to 0? I don't know what 6 over 0 is, right? It's undefined. So it doesn't work. And then if I try -3, then I get 0 over 1. Is 0 over 1 greater than or equal to 0? Yeah, it makes it equal to 0. Okay, one last one. Are we ready? Power through. We can do this. So I'm going to look at my denominators, and I notice that this first denominator factors into x minus 5 times x plus 1. And that's going to be useful to me because if I'm trying to get common denominators, and I already have that x minus 5, so I'm subtracting this other one over, then what do I need to multiply this second fraction by so that it does have the same denominator as the first one? Yeah, x plus 1. So I'm going to multiply by x plus 1 on the top and bottom. So that gives me one big fraction with a denominator of x minus 5 times x plus 1. So write what you think the numerator is. So you should have 2 minus x minus another x minus 1. Do you see it? A lot of people will forget that last negative. They'll write plus 1 on the end. But it's because we have this negative going into both, right? All right, so we get, what, negative 2x plus 1 all over x minus 5 and x plus 1. Oops, plus 1 is greater than 0. So we get 3 critical values. We get negative 1, no, 1/2, right? 5 and negative 1. Make sense? So we put those on a number line. Negative 1 first, then the 1/2, then the 5. Okay, and then we kind of test in each location. You ready? Can we do this? So if I plug in negative 2, negative 2 gives me a positive 4 plus 1 is positive. A negative 2 gives me a negative and a negative, right? So let me write that out. So we have this was a positive on top over a negative times a negative. What do we get? A positive. This next one, so if I try like 0, I get a positive over a negative times a positive. So positive over a negative, which ends up being negative. If I try like 1, I get a negative over a negative times a positive, which is a positive. And if I try like 6, I get a negative on top over a positive times positive, which is a negative. You guys see what I did there? So we want where it's greater than 0, so we want all these positives, and we really don't have to worry about the endpoints in this case because there was nothing that was making it equal to 0, right? We're not worried about, I guess I should say, we're not worried about when it is equal to 0. So your answer should be negative infinity to negative 1, parentheses, union 1/2 to 5, like that. All right. So any questions on that?